Where else I can put that 48? Because I'm going to... Zach, let's go.
AHC, because it's an alternate.
AHC is also... Take a look. 48, also 48. Alternate interior angles are congruent. Anybody seeing how we're going to get to angle ABC? How many degrees in a triangle? 180. Can you find angle HBC now? HBC, I hope so. Go ahead. Find angle HBC. And then what's the relationship between HBC and the angle we're trying to find? Linear pairs, they're supplementary. Done. So when you're ready, what is angle ABC? 1, George, when you're ready?
66.
66 degrees. There we go. Way to start off the test. Any questions there? All right. Watch how quickly this changes to just another unit. So here's our parallel line unit. Now we go to question 2, and we're dealing with similar triangles. All right. This is all across the board. You guys have never experienced this before because of COVID. All right. A test in which it covers the entire school year. Triangles are similar, which is not always true. All right, so what do we know about two triangles that are similar? Sides are in proportion. What about their corresponding angles? Not in proportion, but congruent. Corresponding angles are congruent when the triangles are similar. How are we going to know which angles match up? Use the darn statement. JGR-MST. So J has to be congruent to? J's got to be congruent to? M, because that's the way it's written. So which one does this not happen all the time? 14, 2, G and T, because G and S are the congruent ones. G and T are not. Questions? Matching them up. So we had parallel lines, similar triangles, and now I'm going to end on... I'm sorry, I skipped over 2, just so you know, because that's this unit coming up. I didn't want to do something you weren't familiar with. Question 4. Now we're going to quadrilaterals. Are you kidding me? You got a parallelogram ABCD. Where's my parallelogram? Diagonals intersect. So A, B, C, D. The two diagonals intersect at E. Which one of these would make it into a rectangle now? Which one of these 4 choices makes it into a rectangle? So we got to know our properties. Cold, with no questions. We got to know the properties. All right. AC congruent to BD. Those are diagonals. Is that a property of a rectangle? Do we remember or not? Diagonals congruent. Is that a property of a rectangle? Yes. Yes, that is a property of a rectangle. Diagonals are congruent. Real quickly, choice 3, AC perpendicular to BD. That's not a property of a rectangle, but a property of a? Not if it's a parallelogram already. That's separate family, remember, Romeo. Separate family. Remember, this is a parallelogram. So if I have the diagonals are perpendicular, it would make it a rhombus. Yeah, put that there. Rhombus. Make sure you put that next to 3, please. Rhombus. And if a diagonal bisects the angle BCD, anybody remember what quadrilateral that was, or what type of parallelogram if the diagonal bisects the angles? Remember, we're in the parallelogram family, guys. We're in the parallelogram family. So rhombus, rectangle, and square here we're at. AC bisects BCD. It is a square, but also a rhombus property. Diagonals bisect the angles. All right. That was just 3 questions right there. All right. Questions? Okay. We'll do a couple more tomorrow. All right. And then sooner or later, I'm going to have you guys do some on your own and for homework once we get into that territory. All right. Do not lose this. Do not lose this. Bring it every day with you. Now you can get out your Unit 12 packet. All right, real quick, quiz and test. That's it. We're done. Quiz and test. You got a quiz and a test left here this year. And yes, I do, believe it or not, I do feel bad when I tell you this because we don't have any room for an extra day. The first quiz here is on Monday. This coming Monday, the 23rd. All right, this coming Monday, first quiz, the 23rd. And we're going to finish up the year for the test Friday, June 3rd. And then the following week will be all Regents review. All right, all good? All right, this is it. Last unit, huh? Last unit. Okay. Oh, good. Not that I needed that today. All right. Oh, all right. This unit, last unit in area, it was all two-dimensional figures: rectangle, rhombus, trapezoid. Now we're going to go to three-dimensional figures, something that's got a height and some thickness to it. Those are called polyhedrons. All right, polyhedrons. You guys have heard of a cone before? Sphere, pyramid. Those are all types of polyhedrons. There's three things on a polyhedron I need you to be aware of. The first is every polyhedron has faces to it. All right, they have faces. Not sides, we call them faces. We call them faces. So in this example here of a face, DHGC is a face. Just one of a couple on that polyhedron. The faces are connected by edges. Edges. That connects a face. So anybody just want to yell out what you think an edge is here? DA. Yep, segment DA is an edge. And then what are the edges connected by? Vertices. Vertices. Anybody want to yell out a vertice here? E. There you go. Yep. All right, real quickly. Can you tell me the number of faces, edges, and vertices? All right, let's go to the first polyhedron. Looks like a cube. How many faces does this bad boy have on it? Faces. It's got a front and a back, a top and a bottom, and a right and a left-hand side. So we have 6 faces here. All right, here's where I get nervous. Edges. Don't forget one and don't double count one of them. How many edges does this one have? Don't double count one. Don't forget one. Anybody want to take a stab at it? Molly? 12 edges, yep. And then vertices. How many vertices? I got 8 vertices, yep. Anybody want to go through either of those there? Any of the 3? Anybody know what I call this polyhedron here, number 2? It's pyramid. Yep, we'll talk about those tomorrow. Pyramid. All right, go ahead. Faces. How many faces on this pyramid? 5 faces. All right, be careful. How many edges up here? 8 edges. And how many vertices? I got 5 vertices, 4 at the bottom, 1 at the top. All right, before I go on to number 3, I don't know if anybody's thinking in your head, wow, it's very easy to double count an edge or forget an edge. Here's a way to check. And a mathematician came up with this in the 1730s, had to check to make sure you got the right amount. And this is just, to me, it's just it blows my mind. But I'm also the math guy. But here's how you check. When you add the number of faces and vertices together, and subtract out the number of edges every single time. Every time. I don't care what the figure looks like, your answer is 2. Every time. Try it out on those first 2 right now.
Okay.
6 plus 8 minus 12. What are you doing with a calculator to do that? Really? Come on. 5, and then the second one, 5 plus 5 minus 8 equals 2. It comes out to be 2 every time. I don't know why, but this guy was a stud. All right, 3, faces. How many faces on this one? Anybody know what you call this one? It's a triangular prism. Triangular prism. Today's topic. How many edges?
9.
How many?
9.
9 edges. And then how many vertices? 6. Does that fit into my check? 5 plus 6 minus 9. It's always 2, guys. I don't know how. It's always 2. Questions from you guys? Faces, edges, vertices. All right. Let's talk about slicing these figures. Slicing them. Anybody know that's in the shape of a what there? Cylinder, yep. Cylinder. Okay, let's talk about slicing this. Okay. Let's say I make a horizontal cut right through, and I hold up that cut. What shape is staring you in the face? No, not a cylinder. What's your two-dimensional shape? Horizontal. I hold it up to you. It's a circle, right? It's a circle. So that's that's called a cross section of this cylinder. Cross section. Now, whoa! Let me go vertical on you. Let me open it up. Will I have a circle again staring you in the face? What am I going to have? Rectangle, yeah. And if you guys can't see this visually, here you go. Where's my cylinder? There it is. There's that horizontal cut I was talking about, right? And now let me go the vertical cut. There's the rectangle. Okay, these are all called cross sections. Cross sections. And will I always get something that look at that bad boy right there if I cut it diagonally? What do I get there? Arch? What do we call that? Okay. So it depends on how you cut it, what type of cross section I get. So let's make sure we're good here. Which figure can have the same cross section as a sphere? So everyone knows what, let me put a sphere up here for you. A sphere, there's your sphere. No matter how I cut this, what am I always going to end up as a cross section? Right? Anybody, look, take a look. As I move, it doesn't matter where I slice it or where I cut it, I'm always going to end up with a circle, right? All right, so which one up here do you think will also have a cross section of a sphere or a circle? Which one, when I cut it, I will see a circle somehow? Which one of those 3 up or 4 up there? What do you think? It'll be anybody know what this is called? Cone, yep. If you slice a cone horizontally and hold it up, you'll see a circle. Nowhere else can I get a circle when I slice it of those other 3 figures. All right, what about 2? Which drawing cannot be a cross section of this cone? Which one of those 3 will I never see no matter how I cut this cone? Think about it. This one's a tough one. Let me put a cone up here for you so you can see it being cut. Cone, there it is. All right, so here's my cone. So I definitely get a circle, right? All right, let's keep going. Oh! There's that little arch figure if I cut it diagonally. And if I cut it vertically, I'm going to get a triangle. Which one did I not see up here as I cut it? Yes, the rectangle square here. I will never see that when I cut it. All right? All good. Okay, here we go. Here's the meat of it today, and I've already thrown a lot at you. How to find lateral area and surface area. We're going to look at a prism first. A prism has two bases. Two bases that are congruent and parallel to each other. Anybody, what shape is this base right here? That's a pentagon. So I name it a, ready? Pentagonal prism. I name it by the shape of its base. Okay? I name a prism by the shape of its base. All right, so let's talk about, I'm just going to hop right into it. Ready? Lateral area. What is the difference between lateral and surface area? Lateral area. We just went over a prism has how many bases? Every prism has how many bases? 2. Take them off. Take off the bases, and I want you to find the area of what's left over. All right? So let's take our pentagonal prism. Take off the pentagons. What's left over? What's left over? 1, 2, 3, 4, 5. You find the area of all 5, add them up, you got your lateral area. Okay? So the lateral area is the area of all faces on a polyhedron. And here's the key part. Excluding. Don't count them. Excluding the bases. So if you're asked to find lateral area, you pop off the bases, and you find the area of what's left over. Surface area. That's everything. Put the bases back on and tell me what the area of all the faces are now. That is everything, all right? So surface area is the area of all faces on a polyhedron. I just noticed that. Son of a gun. Okay. I didn't notice I put that there. All right. I know mine looks a little different than yours. I know you guys have number 2, this figure here first. So let's do that one. Find the lateral and surface area. Anybody want to give a name to this polyhedron? What shape are the two bases? What shape are the bases? They are? So this would be a triangular prism. So when we find the lateral area in part A, the lateral area, we are going to take off the triangles. What's left over? 3 rectangles. Find the area of those 3 rectangles and add them up. All right, I can do that. Everyone, the bottom one? Everyone see the bottom one is 12 by, so 12 times 16. I can do that. Ready? Plus, I can definitely do this back one here. 9 by 16. Everyone with me? Ooh, whoa, whoa. What about this one over here on the right? Plus 16 times, that measurement's not there. But we're now into May, mid-May in this course. How can I find that other measurement? Pythagorean Theorem. All right? 9 squared plus 12 squared equals c squared. When you're ready, let me know what that other edge is there. How long is that other edge? When you're ready. 9 when you're ready. 15. Yep. C equals 15. There it is. So there's your lateral area. I took off the triangles and found the area of the rectangles that were left over. So what do you end up with? 576. What do you think about the units here? We just found lateral. Let's do it one more time. Lateral inches. Yeah, squared. Still finding an area just for three-dimensional figures now. Are we okay on that lateral area? All right, now part B, find the surface area. Well, you already did some of the work, didn't you? You already know the lateral area is 576. And now what do we have to put back on? Okay, how many of them are there? Two triangles times the area. What's the area formula from last unit? Triangle. Half base times height. Everyone see that? Lateral area plus the two triangles now I'm going to add back in. And this one should be an easy one here for you because they're right triangles. Since they're right triangles, what are the base and the height? The legs, already labeled for you. 9 times 12. $684 square inches. Yep. On the vocabulary part, are we all right? Lateral versus surface. Okay, take a look at, it's only rain. It's been around for ages. Take a look at the next one. I got to copy and paste it out. So take a look at the next one. Start thinking about the lateral area. First of all, what are the bases? What shape are the bases? Ooh, trapezoidal prism, huh? Take them off. What's left? How many rectangles? Take it off. How many rectangles are left? 4. Can you find the area of them? I'll pull this up, but while I'm doing that, go ahead and try to find the area of those 4 rectangles that are left. I've never heard it rain so hard before. It's my first day on the planet. All right, finally. There we go. All right, so let's see. I got a 3x5er over here on the right. Don't I have a 3x6 staring us right in the face in front? And then I have also a 3x5 on the left. And I'm missing one more in the back. What's the back dimension? 12 by 3. So there are your 4 faces. Yep. We got 15, 18, 15, 36, 30, 66, 4, 84. Yep. Calculator. Huh. Okay. All good? Ready for surface area now. Put those trapezoids back on. So I got 84 already, plus 2 trapezoids at what area formula? Oh, come on. 1/2 the height times base 1 plus base 2. What's the height of the base? Height of the trapezoid. 4. And the bases are 6 plus 12. The calculations are long, but it's not too bad finding what you need. Those cancel out. 12 and 6 is 18. 18 and 4, 36, 72. 156. How's that look? Everyone all good with prisms? Because now the height train really comes in for the next video with me. We're all good? All right. A cylinder. A cylinder. It is still a prism, but with what type of bases? What are the bases? Circles, yeah, that's all it is. It's a prism with circular bases. But we just give it a name called a cylinder. So lateral area. Didn't we just say lateral area you had to pop off the bases? So think about it. Pop off the circle on the top and pop off the circle on the bottom. Don't I still have a cylinder left? So how can I ask you guys to find the area of that? What's left? Like if they're not rectangles like the last problem. All right, let's do this. And I only do this with you because they tell me you're above average here. Right one. Yeah. Okay, everyone ready? Bases are popped off. Agree? So I need you guys to find the area of this blue figure down here. How? I don't get it. It's still a darn cylinder. Ready? Let's open it up now, though. All right, let's not look at it as cylinder. Let's open this bad boy up. And as I open it up, what's it form? A rectangle. Do you know the area formula of a rectangle? Which is what? Length times width. All right, don't copy it down. I'm just going to put length times width because it forms a rectangle. All right, let's go back. What is the length and the width actually? Well, let's go back to the beginning. How can I tell? What is this part of the cylinder right here? I know I have an H there, but it's going to be what? That's the what of the cylinder right there. That side of the rectangle. That's my height. Yeah. So it's going to be something times height. Here's where you're going to make your money with me. What about this side? What do I say this side is of the cylinder? Hey, take a look. Ooh. See it? See that top part there? What do we call that distance right there? That is the circumference. Great job. And what was the circumference formula? Anybody know? Pi d. You just found the lateral area of a cylinder. Congratulations. Pi d, circumference times its height. Pi dh. That is the formula for lateral area of a cylinder. Congratulations. Oh, come on. Oh, I'm not done yet. Still show me you know a little something. What about surface area then? It's the lateral area. What do I pop back on now? How many? Do you know the area formula of a circle? So I'm going to add on what? 2 circles at pi r squared. Great job. So there's the lateral and surface area for a cylinder. All right? So what do you say we blitz through these so I can get to how we end every class from now on? Lateral area of a cylinder to the nearest tenth. Pi d h. What's the diameter? 10. And height? 2. And I am going to keep calling on I got to call on more people for the final answer because on the Regents exam, if you round wrong, for my test anyway this year, if you rounded wrong, I take off a half point. There are no half points on the regions. So unfortunately, if you round wrong, you're going to get a full point taken off. I know, that stinks, but 16, what do you got for me? Nearest 10th. 62.8 centimeters squared. All right, number 4, lateral area, pi dh. Diameter, what are we plugging in? Be careful. Don't use the 3 here. What are you using? 6. Everyone, 6 for D. Diameter. Height is 6 as well. Four, when you're ready, nearest 10th. 4 here? No, I didn't think so. Maybe 3. Okay, I'm doing this one. 113.1 square meters. Any issues before we do surface area? All right, in terms of pi, so make sure you got a pi. Don't plug it in your calculator, put it in your answer. So it's going to be my lateral area pi dh, but now I got to remember to add in those 2 circles at pi r squared. Take your darn time here. Watch what could happen. Pi, what's the diameter? 2, height of 3, plus 2 pi, but now I got to use the radius now. 1 squared. So make sure you know where to plug in diameter and where to plug in radius. All right, it said in terms of pi. Pi times 2 times 3 will be 6 pi. Plus, what do you get over here with the pi? 1 squared times 2. Can you combine those? They both have pi's? You better combine them then. So in terms of pi, the surface area is 8 pi square meters. And then we got one more here before the big one. I always just like to write out the formula. Diameter, 7. Height, 10. Plus 2 pi. What's your radius? Good. Make sure, don't use the 7 again. All right, see if you can leave it in terms of pi on your own. $94.5 pi square centimeters. Okay, anything I can answer before we get to this last big dog one? This is how I like to end class every day in this unit. Let's put our 2 figures right on top of each other and see what the surface area is. Definition of surface area. Everything that is showing on the outside. You cannot count something that's covered up. How many faces does this cube have? 6, right? And they're all everyone agrees they're the same face, right? 5 by 5. All right. So let me do it instead of just doing it all together. So let's talk about the cube first. 6 faces. And what's the area of each of the faces? How do you determine the area of each of the 6 faces? 5 times 5, right? But Are all 6 faces completely showing? No. Everyone see the top one? I do not have a 5 by 5 face because this circle is covering up. Does everyone see that? Surface area is everything that is shown. Hey, basically think of this. Everything you can put your hand on. All right? You can't put your hand on the full face on top. So I need to subtract out what's being covered up. What shape is covering up that 6 face? A circle. So I have to subtract out pi r, which is what for that circle? 2 squared. All 6 faces are not showing. I can only count what's covered up. So that comes out to be a decimal, which I don't round. Is everyone ready for the cylinder that's on top of it? Because I have to do the entire surface area. Everyone ready for the cylinder? Is the entire lateral area showing? Yes? So I'm pi dh. Now, do I want to do 2 pi r squared? Why not? Why not do 2 pi r squared? This base is covered up on the cube, so I can't count it. So instead of doing 2 pi r squared, I'm just going to do pi r squared. Everyone see that? When you're asked about surface area, it's everything that's showing on the outside. So this will end up being pi times 4 for the height, plus pi, radius is 2 squared. And then what am I going to do with the cube and cylinder surface area that's showing? I don't want us to just find them separately. I want to add them together. Those are going to be tough ones for us, but we can't just skip over them. What's up, Romeo?
If there's no rounding directions, do we write out the whole thing?
I'm going to go nearest 10th. I'll give you rounding ones here. Go ahead, nearest 10th. But yes, usually, yes, you are correct. As we talked, write it all out if there's no rounding directions. How are we looking here? 200.3 square inches. I think I'm going to give one of those to you tonight on the homework. You can't count things that are covered up. Great job today. This is how it's going to be for a while. You could. Yeah, you could. Yep. Just one different way of approaching it. Yeah. Okay. Do you have a date in mind?
What, oh, for the quiz?
Yes. I'm not going to put a deadline on it. The only thing I'm going to ask is that